Okay, this video goes over the simulate homework, problems 2, 9, and 15. I went ahead and modeled them all in the same file. You did not have to do this, but I think it made it easier for me to get everything up and running. So before we start, I always for the clock, make sure the clock properties were set at 0 and that the results collection period is 9999. After you've done this, the first problem, it's this vending machine where the service time, is exactly 30 seconds. So I modeled mine in seconds, and it's fixed. It's constant. And the arrival rate is they have 80 per hour. So I had to convert this to seconds. So it's 60 times 60 divided by 80, which gets to, I think, about 45 seconds. So people show up every 45 seconds and they're served in 30 seconds. The time is exponential. I'll go ahead and go through all the models and then we'll look at the results. The second problem, problem 9, is that we've got customers that are requesting requests from a field rep. And they request one every 4 days. So I modeled this in days so that for each customer, the requests are every 4 days they request something. One every 4 days gives me a time between of 4 days, and I model mine in days. And a customer service rep can handle things about one a day. It's exponential. So we've got 5 customers. Every 4 days, they send something, and then a customer rep that can handle something about one a day. And they want you to be able to figure out what the average number of customers waiting, the time they spend in the system, and the idle time of the field rep. And in part D, they want you to add one more field rep. So I took the entire model and duplicated, and I added one more field rep. And I wanted to look at the impact of this one and this one. And then the last problem, number 9, is a priority model where we have people that arrive every, I think it's, they're modeling these in hours. So this is 4 per hour, so I modeled it in minutes. So every 15 minutes, a high priority person requests something, and a low priority requests things 2 per hour or every 30 minutes. So I've got 2 servers, and this server, how they route things in, is based on a priority. So it's going to pull from that one first and pull from this one second. Same thing on this one. Routing in, it pulls from the high priority and then the low priority second. So they want you to be able to determine the system utilization, which is just how busy these are on average. The number of customers in each class that are waiting, so it's the average number here and the average number here. And then the average time waiting, which is the average time here and the average time here. Low and high priority. And then what they want to do is they want to balance the arrival rates. So rather than every 4 and 2, they want to go 3 and 3. So basically what they want is to convert these to both where they're showing up every 20 minutes. So I made that one 60 over 3, and it used to be 60 over 4. I made this one 60 over 3, and it used to be 60 over 2. And we want to look at the difference in the average waiting time for this one. So once I had this model, I duplicated and I changed those numbers. And once you have it, you can run a trial and copy this data and move it toward Excel. Now, if I just look at this right now, the one thing you notice is that we got a really big queue here. And all that means is that one rep is not enough. They're not going to be able to handle these customers. The line is incredibly long. But when you go to 2 reps, you can see that the queue doesn't end with the large line. So it's probably okay. Anyway, so I moved the data over. Now I'm going to look at it in Excel. So I've done a little bit of editing, but this is part A. I mean, this is problem 2, this is problem 9, and this is problem 15. So for problem 2, part A, they want the average queue size, and it was about 0.61 people were waiting, and the time in the system was about 57 seconds. The 30 seconds of that is getting their drink, so that's about 30 seconds of waiting. Not too bad. The second problem, when you model it, remember we have this huge queue, and it's what you would expect, the average queue size. I don't really care what the number is, I just know it's arbitrarily. It's really big, and the queue time is really big, and the percentage of time that the field rep is not working is about 1%. They're busy 99% of the time. When you have systems that are highly utilized, the queues are going to be really bad. So when we add the second rep, when we add that, then our average queue size drops from something really big to something less than one request is waiting. And the utilization, I mean, the percentage of time of waiting drops to about 36%. So the field reps are busy about 2/3 of the time, and about 1/3 of the time they're not busy. Okay, that's that problem. And then problem 15, we have this high priority versus low priority, and for the first one, they're asking for system utilization. Well, if I take the average of these, it's about 74%. So the utilization is about 74% of the time that the workers are working. And then the average number of customers of each class that are waiting. For the high priority, it's less than a person, 0.58. And for the low priority, it's about 1. And then the time that they're in the system is about 8 minutes for high priority and 31 for low priority. So the high priority don't have to wait as often. If you go level load, if you go over here and turn these where they're both showing up every 20 minutes, then the impact is not much. We went from 8.8 time for the high priority, and they're actually waiting a little bit less, 7.8. And the low priority actually went up a little bit. There's more of these, so their time went up slightly. So I don't know if that's good or bad. It's just they ask us to do a what if, and that's what the impact is. The low priority now is bumped up a little bit. The high priority went down a little bit. Okay, hopefully that's the solutions that you need to have solved this homework. If you got questions, please see me. Thanks.